Something strange is happening to science. The United States built much of its 20th century power through an extraordinary concentration of scientific institutions. National laboratories, universities, industrial research laboratories, defense programs, and enormous public investments in fundamental research. So places like Los Alamos, Oak Ridge, Bell Labs, the space program, if you believe in it. Whether we think about the politics or surrounding these institutions or whatever opinions that we have, they demonstrate something very historically important, which is that civilizations can deliberately organize themselves to solve specific scientific problems, such as how do we get people on the moon. But the Manhattan Project is perhaps the most extreme example. Thousands of mathematicians, physicists, chemists, engineers, machinists, administrators, and industrial firms all were assembled around a problem whose solution initially existed only at the very frontier of theoretical physics. I am obviously not interested in producing something of its military purpose. Otherwise, I'd probably be on a black site somewhere reverse engineering some alien technology or whatever. That's a joke. I'm interested in the organizational lesson that the Manhattan Project had for us. But I think the scientific problem of this century might actually be the opposite of the previous century. Instead of concentrating thousands of researchers inside of a handful of secret facilities and, building random new cities or building random new towns that nobody knows about, that somebody randomly, hops into and makes conspiracy theory about, what happens if we distribute them across the planet instead? We already kind of have the primitive infrastructure for this. A mathematician in Serbia can talk to a physicist in California. Somebody in Brazil can find an obscure paper that neither of them has read. A programmer in India can reproduce the calculations. The discussion can all happen on the Discord. And what's kind of cool is the literature can live in a shared research library. Mathematicians can live in LaTeX. The software can live in Git repositories. Computations can run everywhere. I hope you're getting the idea that we live in a completely different century now, which basically every result just can become an object in a growing research archive. That suggests a very different model of scientific organization, and I don't think people have really sat down to consider that, hey, we don't live in the 20th century anymore, and things moved very quickly towards the latter end of the previous century. So, the laboratory itself is not a building anymore. The laboratory becomes a network. It's a distributed, decentralized or centralized kind of character of that network. But the distribution of this network is not necessarily its weakness. In fact, that in and of itself might be its protection. Because no single laboratory whose closure basically can destroy the entire research program. No single university contains its intellectual history. And researchers can enter and leave while this archive persists. So the network itself becomes the institution. So I could envision a type of new research institute. And there are institutes such as the Perimeter Institute and the Fields Institute, which demonstrate that important research organizations do not have to look like conventional university departments. Who would have known? But the internet allows us really to push this idea further. If you could imagine an international institute organized primarily around research programs rather than geography, the first thing it would need isn't a headquarters. The first thing it actually needs is memory. Libraries and archives, research notes, open problems, computational experiments, failed approaches, seminars, code, datasets, and very importantly, the correspondence between researchers. And maybe some maps showing how all of these objects relate to one another. In other words, we need something approaching a research library type economy. A researcher contributes not merely to a paper, but an object in a larger intellectual state space. Or another researcher can find it, transform it, or connect it to something else, compute with it, criticize it even, or extend it. And the library might stop just being merely where research is stored, but the library becomes part of the machine that produces the research. So this kind of leads me to the next point. There's a reason I think we should still experiment with this now. For a long time, taking seriously the notion of economic activity beyond Earth was not completely, it basically was completely absurd, but now it's not. So, rockets are only one component of an interplanetary civilization, so, suppose tomorrow we could cheaply place an enormous amount of mass into orbit. Then what? We need energy systems, materials, autonomous manufacturing, communications and navigation, robotics, computation. We need to make markets, law, research allocation, and even financial systems. So eventually, scientific theories capable of telling us what technological possibilities we have overlooked become very important. And a launch company really cannot solve that problem by itself. No company can. The problem itself becomes civilizational, just as it was in the 1960s. So what is the next great scientific project? Imagine something with the ambition and interdisciplinary concentration of the great scientific programs of the 20th century, but designed for a completely different century. Not particularly a weapons program, not one laboratory or one corporation, not even necessarily one country, but an international network of mathematicians, physicists, engineers, computer scientists, economists, and quantitative financiers, independent researchers, all asking a very long-term question. What scientific infrastructure would actually be required for an interplanetary civilization? Some research would be extremely practical, so just propulsion research, obviously. Plasma physics for energy and maybe electrostatic propulsion. Material science, condensed matter physics, energy, distributed computation, autonomous systems, economic coordination. But a lot of what tends to get neglected this century, which a lot of people have not paid attention to, is progress in fundamental mathematics and fundamental physics. So things like geometry, dynamical systems, studying the properties of stochastic processes, and information theory, control, optimization. These things should remain unapologetically fundamental, because we don't actually know which pieces of the apparently useless mathematics or physics will become the engineering language of a civilization 50 or 100 years from now. And the 20th century repeatedly has taught us this lesson, because abstract mathematics, all things like linear algebra and quantum theory, formed the basis of all of the electronic systems that we have, and this registers in our circuitry that give us computation. And relativity becomes the basis of navigation, information theory with communications infrastructure. Research cannot consist entirely of predicting which technology will be profitable next year. Somebody has to explore the state space. So this makes what we've built together as the jet space pretty funny. Because after all of that, our research institute currently begins with a Discord server. But that is the experiment. Start with almost nothing. Find serious people. Find PhD students, master's students, undergraduate students with research background. Build a library, define problems, create research programs, write mathematics, run experiments, archive everything, and most importantly, connect researchers who otherwise would never meet, and see whether the network can gradually acquire the properties of an institution. The objective, I want to be very clear, isn't to pretend that my Discord server is Los Alamos. We're not trying to cosplay that at a national lab. The question is whether the earliest version of a new kind of institution might initially look deceptively insignificant. Maybe it's a server, a repository, a library, 10 or so researchers, then 50, then 100, then a collection of research programs that begins to emerge. And the archive itself grows, people specialize, projects split and combine. Eventually, the institution exists not because somebody declared that it exists, but because it has accumulated enough knowledgeable people and norms and standards and memory that the network has become persistent itself. That is the experiment. We're trying to build a research institution native to the internet. And we're giving it an absurdly distant and long-term objective, which is to develop some part of the scientific and mathematical infrastructure that an interplanetary civilization might eventually need. And we don't really know where that leads, but that's part of what makes it research in this kind of second-order meta way, because the Institute itself becomes the first research problem. Before thinking about interplanetary systems, we're experimenting with the topology, the governance, memory, incentives, financial funding, redundancy, and information flow of a distributed scientific institution. That gives the project considerably more substance than simply, we made a Discord for researchers. Thank you guys for watching, and I'll see you guys next time. Per Aspera, ad Astra.